Hi guys. Today we're going to be talking about equivalent fractions, and this is lesson 15.1 in our textbook. So the first thing that we're going to talk about before we get into equivalent fractions are just a little reminder of some different skills that we need to be able to do when we're writing equivalent fractions. One of those is being able to find the greatest common factor between two different numbers. So if you look in your notes packet, we're going to find the greatest common factor of 16 and 36. Now, remember, there are different ways that I can find the greatest common factor. I can use a division ladder, make a factor tree, or make a list. So for 16 and 36, I've chosen to make a list. Why did I make a list? Well, 16 and 36 are pretty common numbers that I know off the top of my head, so making a list seemed like an easier idea for that. So when I made my list of all of my factors of 16 and all of my factors of 36, I saw the number that was the largest, so the greatest number that was in common between both 16 and 36 was 4. So I circled the two 4s. Let's look at how did I find the greatest common factor between 64 and 28. Well, 64 and 28 are a little bit bigger numbers. So since I might not know all of those all of the factors of 64 and 28 off the top of my head, I chose to make a factor tree. So after I was done making my factor tree, I circled all of my prime numbers, and then I wrote out my prime factorization over here. So the prime factorization of 64 is written here. The prime factor... And sorry, I wrote too many 2's in there. Sorry. Is 2 to the 6th. The prime factorization of 28 is 2 times 2 times 7. Now the next step I do is if 28 has two 2's and 64 has two 2's, it's like they're dancing partners. So I can highlight the 2's that are in common between 64 and 28, and this set of 2's that's in common between 64 and 28. Why do these 2's not get circled? Because there's not an extra set of 2's down here in 28. So I only circle the ones that are in common. Once I do that, I then multiply. So basically I'm multiplying this set of 2's and this set of 2's, and that's how I end up with 4. So that's a review of how to find two different methods of how to find their greatest common factor. Same thing, when I'm looking for the least common multiple, I might not know all of the multiples off the top of my head of 60 or of 25. 25 is easier than 60. So anyway, so I chose to again make a factor tree. Here's my factor tree, and again, this is something that if you're not good at this needs to be written in your notes. So I make my factor tree of 25, my factor tree for 60. I then write out my prime factorization. This time, when I'm finding my least common multiple, remember, I'm finding the number wherever it appears the most. So for 25, I have two 5's listed. For 60, I have one 5 listed. Where do the 5 occurs the most? In 25. So I'm going to circle those two 5's. Where does 2 appear the most? Well, in 60, because it's right here. And there's only one 3 in 60, but that's still where it happens the most, so I have to circle that number as well. This time, once I have all of my numbers circled, I am going to multiply all of my numbers. So my least common multiple of 25 and 60 is going to be 300, because I'm taking 5 times 5 is 25, 2 times 2 is 4, so that means I'm going to have 25 times 4 times 3. So that's going to be 100 times 3, which is 300. In my last example down here, I'm going to find the least common multiple between 30 and 7. So again, I'm going to make out my factor tree. 7's a prime number, so the prime factorization of 7 is 7 times 1. And then for 30, I ended up with a prime factorization of 2 times 3 times 5. So all of these numbers appear only once, so I have to multiply all of the numbers together. So essentially when I take 30 times 7, I get 210 to be the least common multiple. Right? Using greatest common factors and least common multiples is going to be important when we're writing equivalent fractions, and especially next lesson when we talk about writing a fraction in simplest form. Alright, so let's get into equivalent fractions. So this should be a review for us, but if it's not, I definitely need to know, these are household names now. I need to know my numerator and denominator. Numerator is the top number of my fraction, and the denominator is the bottom number. So these are important terms that you're gonna have to know forever now, right? Oops, sorry. So my numerator tells me it's the number that is part of my whole. So my whole is 4. The part that I have is 2. So that means if I have a circle and I have 4 parts in my circle, I have a total of 4, 1, 2, 3, 4, and I have 2 of those, oops, and I have 2 of those that are filled in. So my fraction is 2 out of 1, 2, 3, 4. 2 out of 4. Alright, so let's look at how do I write equivalent fractions. So, let me change my pen colors here. No, that looks navy. Alright, so first of all, review. Equivalent means equal. So how do I find equivalent fractions? One thing I can do is I can multiply my numerator and denominator by the same number. So whatever I do to the top, I have to do to the bottom. So an easy way to do that would be to, let's just multiply by 2. So if I multiply my numerator by 2, I end up with 4. And if I multiply my denominator by 2, I end up with 30. So 2/5 and 4/30 are equivalent. Let's see. And I can also divide my numerator and denominator by the same number. So again, whatever I do to the top, I have to do to the bottom. So let's look at 2/4 here. So this looks like one where I would be able to divide. So I'm going to, let's divide by, could I divide by 6? No, because that doesn't give me a whole number. Can I divide by 2? Heck yeah, 2 divided by 2 is 1. Whatever I do to the top, I have to do to the bottom. 4 divided by 2 is 2. So I now know that 2/4 is equivalent to 1/2. Now, let's go back here to 2/15. Can I divide 15 divided by 2? Does that give me a whole number? No. So when I'm dividing, I'm going to usually be dividing by my greatest common factor. And that's why greatest common factors and least common multiples are going to be important in fractions. So if I divide my top and bottom number by the same one, I have to have a common factor that can be divided. When I multiply, I can pick whatever number I want to, but whatever I do to the top, you try to finish this sentence, whatever I do to the top, I have to do to the bottom. Alright, now let's do the you try example. So you're going to write 2 equivalent fractions for 8/12 and 3/8. So I'm going to hit pause. Alright, let's see what kind of equivalent fractions we could come up with here. For 8/12, the first thing I did was I multiplied by 2. So I multiplied my numerator of 8 by 2 and I got 16. Multiplied my denominator of 12 by 2 and got 24. So I'm going to have 16/24. 8 and 12 also have common factors, so I divided by my greatest common factor of 4 and got 2 for my numerator, divided by my greatest common factor of 4 for my denominator down here and got 3, so an equivalent fraction could be 2/3. I could also, if you chose to divide by just a common factor of 2, I could also end up with 4/6. So I actually give you 3 different options here. But remember, if you multiplied by a different number, if you multiplied by 4, remember the rule is if I multiply my numerator by 4, I have to multiply my denominator by 4. Whatever I do to the top, I have to do to the bottom. Let's look over here at 3/8. I only have, I'm only multiplying over here to find an equivalent fraction, because I don't have any common factors between 3 and 8, so I can't divide this. So I'm going to end up with, I chose to multiply by 2 and by 3, so I had 6/16 when I multiplied by 2. When I multiplied by 3, I ended up with 9/24. Again, if you chose to multiply by a different number, as long as you multiplied the top number and the bottom number by the same number, you should have an equivalent fraction. Right? So tomorrow, be ready to work on your bell work, and we will see you then, and that's everything about equivalent fractions.